So we're going to take a look at a few examples of this and to see the two types of problems. So note, you're always going to figure out where you start, and then we'll just follow the arrow to where we end up. All right, so let's go ahead and look at one of these together. So let us get rid of the periodic table for now. So our first example here, they want us to know how many grams are in 0.2 moles of beryllium iodide. So we have BeI2. So this is going to be our first example. So we want to find how many moles are in 0.02, or how many grams moles of BeI2. So there's our question. We'll go ahead and look at our DocCam and we'll go through it together. So we want to figure out how many grams are in 0.2 moles of BeI2. So I'm going to put this above us just so that we can kind of use it as our little guide. So notice they give us this number here, 0.02 moles. We're going to start at moles and we're going to go to grams. So for the first step for this though, before we get into this, we need to find what the molar mass is. So for step one, we're going to find the molar mass. So we have BeI2, beryllium iodide. So we'll look at our periodic table for that. We want Be and I. So beryllium is going to be on our left side of the periodic table as element number 4, and it has a mass of 0.9 or 9.04. 9.01. We look up iodine. I is on the opposite end. Iodine has a high mass of 126.90. So we're going to need to combine these two together. So this is our mass of beryllium, 9.01. This is the mass of iodine, 126.90. We know there's 2 iodine, so we're going to multiply this by 2. So we'll do 126.90 times 2. So we should get 253.8. Beryllium here, there's no number. We could times it by 1 if we want. We'll just keep it the same. We'll just add our 2 together. So I already have the number in my calculator. I'm just going to add 9.01. So we get 262.81. That's our first part. Now we have our molar mass of BeI2. We can solve. So if we look at our process, right, we're given moles and we're asked to go to grams. They ask how many grams, we know moles. So we're at moles, we're going to go to grams. So we're going to use this up here. So let's fill it in, right? We're given 0.02 moles times, and we're going to pick the one where moles are on the bottom so it cancels out. So we want the top one. Here we want the molar mass. We found the molar mass. It was this number right here. So it's going to be 262.81 grams. We multiplied this by 1 just because there was only one of them. We could have just left it by itself. So it doesn't matter. We don't have to multiply by 1. We could just add it to it. I just multiplied by 1 to keep it kind of the same process, just to show that there is just one of these, right? We know that if we multiply by 1, it doesn't change the number. So here we'll multiply we already have the number in our calculator, so we're going to multiply by 0.02. So we should get 5.2. We're going to round this, the 6 rounds up, grams. It's all good. Yeah, so for these ones, like, it's not too bad, right? We did the molar mass before. This is our step 2, right? We're just gonna go from what we start with to what we're looking for. So this would be an example of how to go about this example 1. To go how to go about this. Okay, so for problem number 1, we know that they give us 88.1 moles of magnesium. So what we need to know as well is our so magnesium has a mass of 24.30 grams. So our molar mass for magnesium is going to be 24.30 grams. Just because it's a single element. So we're going to start with what we're given, 88.1 moles. And we're going to use this molar mass. So let's look at our map to kind of help us out, right? We're starting with moles, so we're here. We want to go to mass. So we're going to set this up so that we have molar mass over 1. One mole on the bottom. One way to see if you did this right, the units should cancel out. So whatever's on top here should cancel with what's down there. So this is our mass. We have 24.30 grams for every 1 mole. So now what, right? Well, let's look what it says here. If we go from moles to mass, moles to, hopefully grams is going to be our answer. We want to multiply by the molar mass. So we're going to multiply by these two numbers together. So we have 88.1 times 24.30. So we're going to get a large number, and that's okay. So that looks like a 3. So we should get 2,140.83 grams. And that's it for problem number 1. So we'll take a look at the problem 2 together, and then we'll let you finish the rest later tonight. So that's number 1. Let's look at number 2. Okay, so problem number 2, they say they give us 4.5 moles of NaF. So we have to figure out what's our mass of Na and F. So we'll look at our periodic table. Sodium, Na, is 22.99. And fluorine is 19. So you have 1 sodium, 1 fluorine. So we can multiply these by 1, or we can just add them together. So you get 99, 1. So when we add these two together, we should get 41.99 grams per minute. And that would be our molar mass. So this one looks really similar, right? We had moles, we went to grams. We have moles, we're going to go to grams as well. So we have 4.5 moles of NF. And we're going to set it up so that moles are on top here. They're going to go on the bottom to cancel out. This is our mass, so we're going to put that on top. So here it's just going to become similar to the last problem. Moles would cancel out. So we get 4.5 times 41.99. So here we get 188.96. And that would be our answer. So this is problem number 2. So there's a mix of them for the rest of the problems.